So coming to the next lesson, I'm going to talk about a real world example of how diagnostic scan tool communicates with an ECU using scan. Now this is almost like a live project. I request all of you to see this very carefully. You will have a real learning experience if you follow this particular lesson very carefully. Now let's walk you through a real world step-by-step example of how diagnostic scan tool communicates with a vehicle ECU using CAN network. This interaction typically follows ISO 157654. Now, this is something which I reiterated. This 15765-4 is the standard which governs the CAN-based OBD-II, OBD-II, and also ISO 14229, which is a UDS standard. All right. This scenario, checking an oxygen sensor fault. Now, first, what does the technician do? Technician connects the diagnostic tools. The technician connects the diagnostic tools to the OBD-II port under the dashboard, and the scan tool powers on and initiates communication with the vehicle's gateway ECU. All right. Next, the tool sends tester present and session start. The scan tool sends a tester present message. Usually, that message is service 0 by 3E to keep diagnostic session alive. And it also initiates a diagnostic session, whether it is a default session or extended session or programming session, using UDS service 0 by 10. All right. Now coming to the tool to ECU, CAN ID 0 by 7DF, and the data is 021001 00000000. All right. With this message, it is starting the diagnostic session. Okay. Assume it's a default diagnostic session. And now the ECU responds with CAN ID 0 by 7 E8 and data 025001 00000000. So positive response to session. Okay, so the tool is acknowledging that the session has ECU acknowledging that the session has started. So this is where exactly you start. Okay, understand this carefully. This is where exactly you start. Now, when it comes to step 3, the scan tool resends read DTC request using UDS service 0 by 19 subfunction 0 into 02. And when it comes to tool to ECU, the next message will be CAN ID 07DF and data 031902 0000000000. So this is the request for stored DTCs. Now, how does the ECU reply or respond? The ECU replies with the DTC data, for example, P010130 oxygen sensor malfunction. Now, coming to the ECU tool, CAN ID 0 by 7E8, data 0659020101300000, positive response with DTC. All right, and the final response is P0130. Okay, so this is the back and forth which happens between tool and the ECU. Now what is the next step? Scan tool requests live data. Now this is an optional step, but let's touch upon it. To confirm and analyze the sensor's behavior in the real time, the technician may request live data, and he also uses service 0 by 22, and with the help of this service reads data by the identifier. All right, now what actually happens here is, sorry, there's a slight repetition here, it's a small typo, just ignore it. Now when it comes to tool to ECU, CAN ID 0 by 7DF and data 03220101 00000000. So with the help of this particular command, it requests the oxygen sensor voltage, and ECU responds ECU to tool. What is the ECU to tool reply? CAN ID 0 into 7E8. Now data is 0462010168 000000 and O2 voltage 0 by 6A, and which is 1.06 volt. Okay, now talking about the step 5, what is the next step? The technician clears the fault code. Once the issue is fixed, the technician clears the code using service 0 by 14, and with the help of this particular step, clear the DTCs. What is the tool to ECU? What is this particular command? CAN ID 0 by 7DF and the data is 0 to 14FF 0 0 0 0 0 0 0 0 and again 0 0. So this is the request to clear all DTCs. Now how does the ECU respond? Can ID 0 by 7E8. Here it is 7DF, here it is 7E8. Again the data transferred is 0 to 54FF, 0 0 0 0 0 0 0 0 and 0 0. Positive response to DTC clear. Alright. Now when it comes to communication flow summary, we already touched upon the various communication flow, but we will see in a gist manner. One first step is start diagnostic session. Next is keep the session alive. Next is request the DTCs. The tool requests the DTCs, and next step is ECU sends the DTCs, and next the live data is read by the scan tool, and finally the DTC is cleared. Okay, so this encompasses in a very brief manner the entire working or the actual working by the technician to extract the DTC from the scan tool. Now, what happens behind the scenes? Now, CAN frame mechanics. Each of the steps involves CAN data frames with CAN ID 0 by 7DF, functional request 07E to 07EF, and physical request responses to and from specific ECUs. Now, when it comes to payload, it follows UDS or OBD format, max 8 bytes per classic CAN frame. So this is the payload. So what is in conclusion, what does this teach? What does this entire activity teach? The real world diagnostic sequence, it demonstrates how standardized CAN protocols enable ECU communication. It shows how DTCs are read, interpreted and cleared, and it illustrates the modularity and efficiency of vehicle diagnostics in modern cars. Okay, so hope all of you got a clear cut idea about the CAN communication between the scan tool and the ECU.